Hello. Uh, Welcome back to this online tutorial. Uh, we had gone through item one, which was on determining RFM of different compounds. Now, item two was on calculating number of atoms. Now, atoms, recall that atoms, ions, and molecules are particles. So item 2 was on determining number of particles, and in particular, they were atoms given different information. So Roman 1, we wanted to determine the number of atoms in 0.05 moles of magnesium. In simple terms, for Roman 1, we are converting 0.05 moles of magnesium to atoms. So given 0.05 moles of magnesium, how can we determine the number of particles, in particular, which are atoms? So we are converting now moles to atoms. Hope you recall our mind map. Maybe if you don't recall it, let me remind you of this mind map. I hope my screen is visible. Now for the mind map, allow me share this information here. For the mind map, where was it? Mind map. Hope it is this one. Mind map. The mind map was showing the different units which we always encounter. You may be required to convert from moles to atoms, like for Roman 1. We are converting from 0.05 moles of magnesium to atoms. And to convert from those moles to atoms, you need to know what to use. And the information which is supposed to be used in that case, that information was captured in the mind map. I don't know whether it is visible here. I think it is not. It is not visible. Mind map, where are you? It is here. So this is the mind map which we are going to use when converting. And I remember emphasizing it last time. And I interpreted this information in a table. So for this Roman 1, we want to move from moles. We are given 0.05 moles of magnesium. We are taking these moles to atoms. The question is, if we are converting moles to atoms, what do we use? Which relation do we apply? The relation which is applied is here up. 1 mole is equal to 6.02 times 10 power 23 particles. This information, it must be on your fingertips. However, it is always provided at the front page of the question paper. They just put it there. They don't tell you that for this item you will use this. No, for them they just tell you that 1 mole is equal to 6.02 times 10 power 23 particles. However, for you to be able to apply it, you must know that this relation works when I'm moving from moles to atoms. And to know that, you must have this mind map in your head. So interact with this mind map on a daily basis. We are going to apply this map in all those different Romans. Therefore, heading back to my item, where is it? My item is here. We are converting 0. The question wanted us to calculate number of atoms in 0.05 moles of magnesium, and we have seen what to use. Therefore, in this case, I'll come and say 1 mole is equal to 6.02 times 10 power 23 atoms. The particles here are atoms. So 1 mole is equal to that. If 1 mole is equal to this, then what of the 0.05 moles? What shall we do in that case? You have a case where one cow costs 1 million Ugandan shillings. One cow costs 1 million Ghana shillings. What of 5 cows? So if one cow costs 1 million UG shillings, then 5 cows will cost 5 times 1 million. Therefore, if 1 mole is equal to 6.02 times 10 power 23 atoms, 0.05 moles will be 0.05 times 6.02 times 10 power 23 atoms. And computing this, we obtain 3.01 times 10 power 22 atoms of magnesium. Therefore, 0.05 moles of magnesium are equal to this number of atoms of magnesium. Alternatively, we have another method. However, this other method does not differ much from this first approach. The second method, I call it a technical method. It is a bit technical. Why I term it like that, you will know with the time. But we have another approach, and that approach, I'm terming it as a technical approach. So for the technical approach, what shall we do? We shall say, instead of saying 1 mole is equal to 6.02 times 10 power 23 atoms, for the technical approach, we shall say that 1 mole contains 6.02 times 10 power 23 atoms of magnesium. Then we shall say, what of the 0.05 moles? This will contain 0.05 times 6.02 times 10 power 23 atoms of magnesium. And computing this, we obtain the same answer, 3.01 times 10 power 22 atoms of magnesium. Alternatively, this one can as well work. However, it is a technical approach. You will know with the time why I'm calling it a technical approach. So that is for Roman 1. Then for Roman 2, we had 80 moles of sulfur. We wanted to determine the number of atoms in 80 moles of sulfur. So what do we use here? You have to know, what am I given? I am given moles. What do I want to find? I want to determine number of atoms or number of particles. And to move from moles to particles, what relation do I employ? Now you have to think about the mind map. What does the mind map say? Maybe to recall, I'm going to re-echo this mind map always, so that it sticks to your mind. The mind map is here. I'll remind you that the mind map says that if you want to move from moles, now we have 80 moles of sulfur, to atoms, what do you employ? You employ 1 mole is equal to 6.02 times 10 power 23 particles. That is what the mind map says. As a result, having noted what the mind map says, we shall proceed with our calculation. The calculation is here. Still here, having seen what the mind map has informed us, we shall say that 1 mole is equal to 6.02 times 10 power 23 atoms. Then what of 80 moles? What of 80 moles? I have told you, you have to think about this in a basic way. 1 mole is equal to that. Put it in a real life situation. One black book costs 5,000 shillings. Therefore, 8 black books will cost which amount? So if one black book costs 5,000 UG shillings, then 8 black books will cost 8 times 5,000. Therefore, here, 8 moles will equal to 8 times 6.02 times 10 power 23 atoms. And computing this, we obtain, if we multiply 8 times this Avogadro's constant, we obtain this as our outcome. Alternatively, this also has a technical approach. Therefore, here the technical approach still says that 1 mole contains 6.02 times 10 power 23 atoms of sulfur. What of the given moles? The given moles in this case are 8 moles. The 8 moles contain 8 times 6.02 times 10 power 23 atoms of sulfur. And computing that, we obtain this as the number of atoms of sulfur. That is for Roman 2. Then for Roman 3, what do we have? Roman 3 now here, the thing changes a bit. The question says that calculate the number of atoms. So we want to calculate the number of atoms given 0.65 grams of chlorine atoms. So in simple terms, here we are moving from, recall, you have to understand what you are given. So in this case, we are given mass. Hope you see that. We are given mass. What do we want to find? We want to find number of atoms. Then what does the mind map say? I'm going to remind you of this mind map every time I work out such items. The mind map says that, hope you've noticed what we are given. We are given mass. We are given 0.65 grams. Grams, that is mass. We want to move from mass to atoms. Atoms are particles. Therefore, the mind map says that, here is the mind map. Hope my screen is visible. The mind map says that from mass, you go to moles, and then from moles, you go to atoms. Therefore, we have to move from mass to moles, then to atoms. In summary, so we have to move from mass to moles and then to atoms. And to move from mass to moles, this is the relation which we apply. 1 mole is equal to molar mass. That is, if we want to move from mass to moles, what do we use? 1 mole equals molar mass. And the molar mass, that is the same as RFM. So this can be obtained. And from moles to atoms, this is what we apply. Therefore, going back to my item, hope my screen is visible. Going back to my item, so we want to move from mass to moles and then to atoms. So we first move from mass to moles. What do we apply? If we want to move from mass to moles, we have seen, I'll remind you about, I'll keep on reminding you about this mind map. The mind map says that, my screen is visible. The mind map says that if you want to move from mass to moles, what do you use? 1 mole is equal to molar mass. Molar mass is the same as RFM of that given thing. So in this case, what do we have? in this case, we have chlorine atoms, because we are given 0.65 grams of chlorine atoms. By the way, you have to recall that chlorine gas and chlorine atoms, those two things are different. So we want to move from mass to moles, and we use 1 mole equals molar mass. So in this case, we shall say that 1 mole is equal to the molar mass of chlorine atom is, from the given information in the bracket, it is 35.5 grams. Therefore, 1 mole is equal to 35.5 grams. So in simple terms, I want to convert this mass of 0.65 grams to moles. So, and to do that, we use what we know. 1 mole is equal to 35.5 grams. Then we ask ourselves, how many moles are in 0.65 grams? So we don't know these moles. Maybe you can call them an unknown, like X or Y, but I put a question mark. We don't know them. So they are unknowns. Therefore, cross multiplying, we shall have 0.65 times 1. We shall have, maybe I should put this clear. If we cross multiply, this is what we shall have. Cross multiplying, we shall have 1 multiplied with this, and then 35.5 grams multiplied with an unknown. This unknown can be X. Therefore, if we cross multiply, we shall have 35.5 X. 35.5x is equal to 1 times 0.65, and 1 times 0.65, that is the same as 0.65. So this is what we shall have. So 35.5x is equal to 0.65, and making x the subject, we shall have to divide. We shall have to divide. Making x the subject, we shall have to divide both sides by 35.5. So over 35.5 over 35.5. So this cancels out with that. Therefore, x is equal to this. Hope you've seen. Therefore, to determine the number of moles, it is just a matter of dividing the given mass, because this is the given mass, 0.65, the given mass over the molar mass, given mass over the molar mass, or the RFM. Therefore, allow me take this thing off. Allow me erase it. So after removing it off, therefore, this is what we shall have. I haven't removed this. Anyway, let me also put it off, this cross multiplication. Let me also put it off. So heading back to our item, therefore, the given, in summary, the given number of the required number of moles will be 0.65 over 35.5. Therefore, to convert from mass to moles, it is just a matter of getting the given mass over the RFM of the given, over the molar mass or the RFM of the given substance. And computing this, we obtain this as the required number of moles. Now we have we've progressed from mass to moles. Now we have moles. Now we can progress from moles to atoms. And to progress from moles to atoms, what do we use? From the mind map, the mind map says that we use 1 mole is equal to 6.02 times 10 power 23 atoms. What of the moles that we have now? What of the 0.01831 moles? Those moles will equal to 0.01831 times 6.02 times 10 power 23 atoms. And therefore, calculating that, we obtain this as the required number of atoms of chlorine. That is approach 1. However, we also have the second approach. The second approach is a bit technical. Let us also go through it. The second approach, we want to determine the number of atoms given 0.65 grams of chlorine atoms. In simple terms, we are moving from mass to atoms. We are moving from mass to atoms. So we want atoms. We want atoms. In simple terms, we want atoms. So if we want atoms, the mind map, what the mind map says, this is what the mind map says. The mind map says that 1 mole contains 6.02 times 10 power 23 atoms of chlorine. So since I have noticed that I want atoms, now you think about the relation that has atoms. You think about that relation that has atoms, and this is the relation that has atoms. 1 mole contains 6.02 times 10 power 23 atoms of chlorine. However, the mind map, that mind map also says that, let me share it again here. The mind map says that 1 mole is equal to molar mass. So if you have 1 mole, 1 mole is the same as molar mass. 1 mole is the same as molar mass. That is what the mind map says. So why am I relating moles to mass? I am relating moles to mass because in the item I have mass. In the item I have mass. So since in my item I have mass, at first I have said that 1 mole contains 6.02 times 10 power 23 atoms of chlorine. Now I have atoms which are required. However, the moles, I don't have them. The item does not comment on moles. Therefore, you have to replace moles with mass. And to replace moles with mass, the mind map says that 1 mole is the same as RFM. So if here we have chlorine atoms, where I have 1 mole, I replace with RFM of chlorine atom. And what is that? That is 35.5 grams. Therefore, 1 mole is the same as replacing it with 35.5 grams contain 6.02 times 10 power 23 atoms of chlorine. Hope you've seen how I have formulated this second step. How have I formulated it? This is what the mind map says that if you want atoms, I will say 1 mole contains 6.02 times 10 power 23 atoms of chlorine. However, that mind map still says that 1 mole is the same as RFM of the given substance. So in this case, we have chlorine atom. So therefore, 1 mole is the same as saying for chlorine atom, 1 mole is the same as having 35.5 grams. Contains 6.02 times 10 power 23 atoms of chlorine. So 35.5 grams contain this. What of 1 gram? 35.5 grams contain this. What of 1 gram? It's like you have 35 students. Listen to this attentively. 35 students consume. 35 students consume 70 kilograms of potion. 35 students consume 70 kilograms of potion. 35 students consume 70 kilograms of potion. 1 student, on average, what does 1 student consume? So if 35 students eat 70 kilograms of potion, 1 student, on average, will consume 70 over 35. Hope you've noticed that. 35 eat 70 kilograms of potion. 1 student on average will consume 70 over 35 kilograms of posho. Therefore, if 35.5 grams contain this, 1 gram will contain this over 35.5 atoms of chlorine. What of the given grams in the question? In the question, we have 0.65 grams will contain. We shall have this times 0.65. These are now atoms of chlorine. And computing this, we obtain 1.1 times 10 power 22 atoms of chlorine. That is method 2, a bit technical and a bit easy. I have endeavored to explain how it is worked out. That is for Roman, this is for Roman 3. Roman 3 and the item 2. Then next we have item 3. I don't know how I forgot to collapse this. A moment. Okay, let me repeat. So for item 3, we want to determine, item 3 says, determine the weight of 3.0 times 10 power 23 atoms of calcium. Let me collapse this. I think this thing is not going to make my explanation better. Allow me collapse it. Sorry for that delay. Where is it? This is item 3. Item 3, determine the weight. Determine the weight. Where are you? It is here. Determine the weight. Determine the weight. I need to make you collapse. Determine the weight. Hope it is now collapsed. Let me run this. After running it, then I'm going to cut off this. Leave. Hope now it is off. Hope now it is off. Okay, it is off. It is off. I want to share it again. Where is it? Sorry for that, but I have to make my explanation a bit clear so that you understand me very well. I do not have to just jump onto things. That's why I have to make this adjustment so that we move on the same page. Now, having made that adjustment, now I can share my screen again. Hope now it is visible. It is visible. It is visible. We have seen all this information. Item 3, where are you? Item 3. Sorry. Now, this is what I wanted. Item 3 says we want to determine the weight. That is mass. We want to determine the mass of 3.0 times 10 power 23 atoms of calcium. In simple terms, we are given atoms. We are given particles. We want to determine mass. What does the mind map say? The mind map says that if you want to determine atoms, let me first put this off. The mind map is here. Where is it? It is now off again. Okay, sorry. Sorry for that. The mind map, where are you? Mind map is here. Here is the mind map. The mind map says that we want to move from atoms to weights. We want to move from atoms to weight. The mind map says that from atoms you go to moles. That's how it says. From atoms, from particles. From particles you go to moles, and then from moles you go to mass. So to move from atoms to mass, you have to go through moles. Therefore, this is what we are going to do. To determine the weight, in this case, we have to go through atoms, then to moles, and finally to mass. And to move from atoms to moles, the mind map still says that from atoms to moles, the mind map says that from atoms to moles, what do you use? From atoms to moles, we use 1 mole is equal to 6.02 times 10 power 23 atoms. That is if you want to move from particles, which are atoms, to moles. This is what we use. We use the same relation in simple terms. Still from moles to mass, we use the same relation. So from atoms to moles, this is the relation which we are going to use. So allow me share my thing again. Therefore, we shall say that 1 mole is equal to 6.02 times 10 power 23 atoms. So we want to determine, remember we are moving from atoms to moles. So we ask ourselves, how many moles are contained in 3.06 in 3.01 times 10 power 23 moles. So I put a question mark here, or you can label it using an unknown. So how many moles are in 3.0 times 10 power 23 atoms? Still here we shall cross multiply. So we have 1 times this figure here, and our unknown will be multiplying the Avogadro's constant. Therefore, in simple terms, the number of moles shall be equal to the given particles, which are, after cross multiplying, we shall have this times 1. So this will remain the same. Then the unknown will be multiplied by 6.02 times 10 power 23 atoms. So dividing, we shall have the given atoms over the Avogadro's number. So the number of moles will be the given atoms over the Avogadro's number. And computing this, we obtain 0.4983 moles of calcium. Now we have our moles. So we can convert them to mass. From moles to mass, what do we use? We use 1 mole is equal to molar mass. 1 mole is equal to molar mass, and for calcium, that molar mass is 40. For calcium, it's 40, so 1 mole is equal to this. What of the calculated moles? The calculated moles, the 0.4983 moles shall be equal to 0.4983 times 40 grams. And computing that, we obtain 19.9 grams of calcium. Therefore, that is the first alternative. Then for the second alternative, it is still a bit technical. What does it say? Alternatively, if we want to determine the weight of 3.0 times 10 power 23 atoms of calcium, still we shall use 1 mole contains 6.02 times 10 power 23 atoms. However, here we have weight. We have weight and atoms. So these moles, and we want to determine weight. Therefore, allow me change this. If I say that 1 mole contains 6.02 times 10 power 23 atoms of calcium, this is the same as saying 6.02 times 10 power 23 atoms are contained by 1 mole of calcium. Now, some of you are going to ask, why has the man changed the statement? I am changing the statement because I want, the question wants us to determine the weight. What I want to find, I want it to be on the right-hand side. Always ensure that what you want to calculate is on the right-hand side. Therefore, that's why I have changed this statement. What is on the right-hand side is what I want to find. then what I am given is what is on the left-hand side. This is the left-hand side, and this is the right-hand side. So if 1 mole contains 6.02 times 10 power 23 atoms of calcium, this is the same as saying 6.02 times 10 power 23 atoms are contained by 1 mole. And recall that 1 mole from the mind map, 1 mole is the same as molar mass. So where I have 1 mole, I'm going to substitute molar mass for calcium, which is 40. Therefore, we shall say 6.02 times 10 power 23 atoms are contained by 40 grams. So if these atoms are contained by 40 grams, what of one atom? What of one atom? Recall, the other time I said that 35 students consume 70 kilograms. 35 abayizi 35 balya kilo 7. So muizo on average abalya meka? Muizo on average abalya 70. So one student will consume 70 over 35. So on average, implying that one student consumes 2 kilograms on average. Therefore, 6.02 times 10 power 23 atoms, if are contained by 40 grams, therefore, one atom will be contained by 40 over 6.02 times 10 power 23 atoms. What of the given atoms? The 3.0 times 10 power 23 atoms will be contained by this times 3.0 times 10 power 23 grams. And computing that, still we obtain 19.9 grams of calcium. For item, that is for item 3. Then finally, for item 4, we wanted to determine the number of moles. Item 4, we wanted to determine the number of moles occupied by 300 centimeters cubed of ammonia at STP. So we want to move from moles to volume. What does the mind map say? The mind map says that if you want to move from moles to volume, the mind map says that from moles to volume of a gas, the volume can be at STP or at RTP. The mind map says that we say that 1 mole is equal to 22.4 liters, that is at STP, or 24 liters at RTP. Now, 22.4 liters, this is the same as having 22,400 centimeters cubed, or 22.4 decimeters cubed. I think you recall that. That is at STP. Then at RTP, this is the same as 24,000 centimeters cubed, or 24 decimeters cubed at RTP. Therefore, from moles to volume, this is the relation which we use as far as the mind map is concerned. Therefore, going back to my presentation, we shall have 1 mole is equal to 22,400 centimeters cubed. Since the item has information, has volume in centimeters cubed, so 1 mole is equal to 22,400 centimeters cubed. So I ask myself, how many moles? Allow me first stop here. I think this thing wants to go off. Allow me first stop here.